welcome to my channel, Gecko Libre. Today I'm going to talk about my second quad ever. It's the Aurora 90 brushless build as recommended by Stu from UAVfutures. And it is my first build. My very first drone actually is the Eachine 010. I wanted to start out with something like this because it wasn't quite as aggressive, I would think, as a 5-inch quad, and I wanted to build something myself so I could learn from the process. So as you can see, I've made some changes over time with this quad after flying about 100 battery packs through it. Most noticeably is I used a Dremel tool to cut off the prop guards on it. And the reason why is because those kept on breaking after a bunch of crashes. They're pretty hard crashes, so they were durable, but I got tired of super gluing them back together, so I decided I'd rather replace props than to super glue a prop guard again. Also, speaking of which, all of the components that Stu, which I can link in the description below, are what I used on this build. I've got the 8000 kV motors instead of the 1000 or the 10,000, so that's the only difference there. And I modified the transmitter to have a whip antenna. It's a Craze Pony whip antenna. The signal isn't as good as the original cloverleaf that it comes with. It definitely limits your range, maybe by half. But the upside is that it's much more durable and I don't have to worry about it getting twisted and bending it back and busting the inside of the wire. Another thing I've done is I rotate the blades outward instead of inward. So I do it like that, and same on the back side. And the reason why I do this is because I was getting lots of wet grass on the insides of the stack, and also that was pretty much the only reason why I did it, and I wanted to experiment with it, and I didn't really notice a difference between outward and inward performance wise. So I'm going to take this apart for you, and I'll talk more about the stack and how I laid it all out, just a general walkthrough. One thing to note is that I use the DYS 2030 propellers because they are the smallest diameter that I could find without rubbing against the screws on the frame. All the other propellers I've tried, the Gem Fans and the Racer Stars, those all rub, and these ones are the only ones I could get to fit, and they work just fine, and they're quite durable. I think they're polycarbonate. I'm happy with them. The only thing is they don't come with screws to hold them on, so I had to use the screws from the Racer Star propellers that were provided, but I had to use a Dremel to grind them down since the hub height is slightly smaller, and so those screws were actually touching the motor windings if I didn't grind them down. So that's one thing to note about the propellers. So there was a problem in earlier models where this aluminum standoff for the prop guards was too tall from the distance from here to here. Originally they were about 12 millimeters high, and that was causing the propellers to hit right there. And what they did is they shortened it to 10 millimeters, I believe, so there's more clearance for the propeller. Now that's a great help. So the newest Aurora frame kits now have these shorter standoffs, so that fixes that problem. But still, that doesn't fix the problem of the propellers sometimes rubbing against the standoff screws, because when you crash, the blades will get all wonky, and some of them will be low, some of them will be high. The low ones are going to tend to hit these screws and they'll rub a little bit. So it helps to have fresh props for this thing. Another pet peeve of mine is that the USB port is impossible to access with the canopy still attached. So another plus of me chopping off these prop guards is that I only have 4 screws to undo instead of 8 whenever I need to update the settings in Betaflight. So it'd be nice if the frame made it more accessible to plug in the USB. And I don't think there's any orientation you could have chosen to make it more accessible. Maybe, yeah, unless you have some kind of funky USB cable that comes in at a 90-degree, you're not going to be able to access the USB while it's assembled. You're going to have to take off the canopy. So that's kind of annoying every time you have to adjust something in Betaflight. Okay, so I got the cover off, and this is the general orientation of my stack. On the right hand side, from the copter's perspective, I stuck the receiver underneath the 4-in-1 Racer Star ESC, and then I have the cable going over the top and connecting to the receiver pins on the clone BLX, Pico BLX. Another thing is the way I routed my battery is, how did I do that? Right, okay, so I have the main wires coming underneath the chassis and then over the ESCs and then soldered underneath the flight control board. And the reason why I could do this, I did this, is because so I could also in parallel solder the connections for the ESC, which go from the top back over and around and connect to the ESC 4-in-1. And then the wires, the signal wires coming from the ESC control board, which I can show you in more detail later, they go over the top of this umbilical that I made, and they spread apart and go to each of the motor signal wires on the control board. And I think there was a ground wire coming out of this thing, and I ended up just cutting that off. And I also cut off the 5-volt ESC supply because I didn't need that as well. And it works just fine without that. I only have the signal wires connected to the flight controller. The antenna from the receiver goes underneath the whole thing and comes back around along the same wiring harness. And that's so I could keep most of the wires in one place so that they could sit between the rails of the upper frame. That way they don't get hit by the props. So I'm going to take apart the stack a little bit and see if there's anything I can show you in more detail there. Okay, so I took off the flight controller, and on the bottom you can see how I soldered the main battery voltage leads to the bottom. And what I did to secure the 4-in-1 ESC is I took a soldering iron and I burned through the heat shrink over all the holes, and I just screwed the standoffs directly on top of that. Now it made it pretty clean, and the only thing is that the heat shrink causes the stand-ups to bend outward a little bit, so I had to put the flight controller on and then tighten them down all the way using needle nose pliers like that. And so when they bent outward, they would kind of clamp sideways outwardly on the flight controller. And here you can see a better detail of the receiver I have. I'm using the FlySky A8S receiver, and it's the one with only one receiver antenna. And I get really good range with this thing. Like, it's definitely good enough for me, because This quad I tend to keep a little bit closer because I don't want to lose it, because I use it for keeping my skills and training up. So it's definitely far enough for my taste. It definitely outranges the video signal. So I use the FlySky i6 controller, and I modified it with the internal SMA pigtail with the UFL connectors to connect to the transmitter on the inside. And with that, I use these I think they're like 5 dB Wi-Fi antennas, and so I get really good range with my FlySky, much further than I could ever go with the video signal. And the video transmitter is a Eachine TX03. It's the switchable from 25, 200, and 600. I typically use 200 because the 600, with this transmitter, it overheats like quite quickly. So when you turn on the quad, you have to have everything ready to go and fly. Because if you wait like maybe 10 or 20 seconds, the signal will drop out from overheating. So you have to pick it back up and blow on it a few times. And the way I mounted the 3-in-1 transmitter camera antenna thing is they supply you with a piece of foam that attaches to the aluminum plate here, and it's not very thick, and also it doesn't work quite well with the geometry of this transmitter because it has a square section that kind of cuts into the foam, and it still directly contacts the aluminum. So I had Jello, a little bit of Jello with that foam setup. So instead I had some thicker foam tabs that are just rectangular in shape and rest along the sides of the transmitter, and it had a sticky adhesive on one side, and I stuck it to the aluminum plate, and I'm holding the camera against the plate with just a single rubber band that's crisscross over twice. And that setup works very well for me because it's secure, but I can still adjust it if I want. If it's a little bit cockeyed, I can push it and then swing it back over, and that way I can get it straight the way I want it. And also it dampens a lot of the vibration. You're going to notice that there'll be like very little vibration in the video feed, which is very good. I was pretty happy about that. But when you start crashing and your propellers get all janky, you're going to get a lot more vibration, and that's when you start seeing Jello. And I still see a little bit of Jello. You'll see in the video with this setup, and it's not too bad though. It's perfectly flyable. And these motors have been working great. One of them is a little rattly. It's the back left one, this one here, but they work just fine. And this quad has been very reliable for me for the most part. There's only been a few tweaks and changes there. As far as the build, back to the build again, I zip tied each of these bundles of motor wires just to keep them out of the way of the props, so they don't come up. And as far as damage goes, I did break one of the spars here. If you can't see that, I could try the microscope too. It broke right there, and that was from a fall from about 50 meters where I forgot why, but I basically dropped the quad, and it had a controlled fall from about 50 meters straight onto hard ground. It was grass, but it's pretty hard, dry ground, and that pushed the battery into the frame and busted that one spar. But what I did is I super glued it, and it hasn't come loose since then. I used a similar repair technique for the prop guards, but I broke so many edges on the prop guards I just took them off, and now I fly with propellers to help me get used to flying without prop guards for when I do my 6-inch build, a chameleon. This guy here. One thing about it is that it's challenging for a very first build because everything is so small. Like building the chameleon, what I'm doing right now, it's much easier compared to this because just the contacts, the pads, they're all bigger and the spacing is much easier to handle. Like with this, I had to do funny stuff like jam this underneath there and then use the nylon standoffs to kind of clamp it down. I had to get a little creative with my wire layout and all that just to make sure all the wires didn't do that. So those are kind of things you don't have to worry about as much with a 5 or 6 inch quad. So I still recommend building this for your first quad just because it trains you for working with very small electrical components, and then when you go up to a bigger quad it makes it a lot easier. And yeah, it's kind of like when Goku was training on the spaceship at 50 or 100 times gravity, and then when he gets back down to the planet he's like super strong. It's like that. And I use a XT30 connector as well. People recommended that because it prevents brownouts. I've never experienced a brownout before, but I just went ahead and installed an XT30 because it's very secure and small, and it works. One performance issue I had with this Aurora is that it would have a tendency to kick. And what I mean by that is if I was going into a turn and I leaned too far this way, it would kick over the opposite way in order to try to compensate for something. And it would also have bad oscillations when descending from like either straight down or at an angle. Whenever it was descending, I would get these large oscillations about that big in amplitude, and it was very annoying. Like, and it would also happen even if I was going straight. If I pitched too far forward, it would kick back, wanting to try to recover. And I messed around with the PIDs and the rates, and that didn't do anything. That never solved the problem. So that made me think that is a physical phenomenon, like maybe because this frame is so top heavy. Well, it's actually bottom heavy because the battery is so much heavier than the rest of the components, but maybe because it's got so much mass spread out vertically, that caused it. But I did find a solution eventually, and it took me a long time. It took me about like 70 battery packs to figure it out. What I did is I went into Betaflight, and under the PID tab, if you scroll down to the bottom on the right, there's TPA, and it's at default set to 0.1. And what I did is I bumped it up to 0.25, and I set the TPA breakpoint as the standard 1650, and I went and flew it, and I noticed that a lot of the oscillation is gone. I could be a lot more aggressive on my turns, and when I was descending I was getting much less oscillation. And so today I'm going to set my TPA to actually 0.5 because since doing that I've gotten more aggressive with my flying, and it's really helped a lot. I just have to mess around with the breakpoint to make sure that it doesn't, because what the TPA does, I think, is it at high throttle it dampens the PID rates, the PID coefficients, so it makes them less as potent, I guess, at high throttle. And I have no idea why that has an effect on this whole kicking phenomenon that I get. You'll see a little bit of it in the video, and because I still get it, but I don't know why it helps, but it does. One thing I forgot to mention is that oh yeah, this is how I put on the battery strap. I used the large slots in the frame and then run it under, over, and under the frame. One thing to note is that I broke one of these nylon screws. These standoffs for this frame are not M3, they're M2, so they're kind of harder to find. So I'd recommend buying from Banggood the little Aurora standoff kit and also some extra screws, because some of the frame screws can start to fall, especially when you're first starting out and you're not if you don't use the blue thread locker, which I didn't at first, and I was losing some screws. So I'd recommend extra screws, the extra screw kit for the Aurora 90, and also the extra standoff kits, because you might break a screw like that. I'm going to keep it like that for now because it still works and it's fine, but I've got some more screws coming in the mail. Okay, so I'll show you some flight footage so you can see what this thing is capable of.